This is part 2 of the heat transfer calorimetry video for our notes for thermochemistry. So we are looking at example 2, where we're going to be finding the calories burned in a food sample using this little makeshift calorimeter here. And you can see that the peanut is being burnt underneath a metal can, which is going to kind of act like our container of heat transfer to keep the heat from getting out or in. Not perfect, but it's going to be enough to do the job. And then remember that whatever heat is released by the peanut is going to be the same amount of heat that will be absorbed by the water. So we have kind of this energy transfer, conservation of energy, that the heat given off by the peanut is going to be the heat, the heat given off by the peanut is the heat absorbed into the water. So they will be equal and opposite. One's releasing, one's absorbing. So let's go ahead and do this problem. And again, we're going to be using Q equals MCAT for our calculations. Remember, Q is energy, M is mass, C is specific heat, and delta T is temperature. And the beauty of calorimetry is that we know C of water, 4.184. So we will always start with water and then kind of work backwards if we need to find more information about the sample. So we have our peanut that's burned. The heat given off by the peanut causes the water to heat up. The water absorbs all of the heat from the peanut, just like we talked about. The can contains 100 grams of water, so there's our mass of the water. And it's temperature changed, so there's temperature start, temperature final, both of the water. And we want to calculate the heat absorbed by the water during the burning of the peanut. So if we're finding heat, that's Q. We have all the other information. Mass is 100. We know C is 4.184 of water always. And then our temperature change, find the difference between our start and our end point. And so if we do that, we will find that the temperature change here is 42.2 degrees. And then we just need to find this product, and that is our energy transfer. Looks like it comes to be 17,656, just leave some decimals on there, 0.48 joules, okay? So that's what our calculators give us. Next it says, according to the law of conservation of energy, what is the heat, so Q, released by the peanut? Well, what we drew here at the beginning, all of the energy absorbed by the water is going to be equal to the heat released by the peanut. So our Q, heat released, is going to be the same exact amount of energy that was absorbed by the water. So this is released or burned from that peanut. And this is going to be helpful, or actually is the way that food chemists discover or calculate the calories. Calories are just another unit of energy. Right now we have it in joules. So we're just going to do this little extension and convert this to calories. Remember that calories is a capital C, or food calories, that's 1,000 of little c calories, which is why our conversion factor here says 4,184 joules rather than 4.184 joules. That would be in little c calorie. So we will use this as a conversion factor to change our joules into big C calories. So if we use that as a conversion factor, we get 4.22 calories in this sample. Now the next part says this peanut is 0.80 grams. So this is our sample. So we're going to use that as another conversion factor for this next part. Our whole sample was 0.8 grams. We just calculated that sample is 4.22 calories. So there's another conversion factor we have. We want to know how many calories are in 1 gram of peanuts. So that's our given. Then we can do a little conversion here and find that in 1 gram of this sample, do the math, we've got 5.275. So there's our calories per gram in this peanut. And you can find that just the same way that we found the information about the metal. We've got Q equals MC delta T. Always start with water because we know its specific heat. You won't know the specific heat of your sample unless you find the water first and then work backwards. So we really could find the specific heat of this peanut if we were given its starting and ending temperature, but we do not have that. So this is the information though that we really do care about for food. We want to know its calories because the amount of energy that is burned when the food sample is digested, that's the amount of energy it provides for your body. And so whenever you read calories on the food facts and the nutrition label of whatever it is you're eating, you are reading how much energy is released from that food sample per gram.